This stuff all comes out of unit circle again. When you go back and you start looking at just, come on guys. When you go back and look at just the whole idea of what tangent is, remember tangent is y over x. Okay? Tangent is y over x. So as you go through your your ordered pairs and you look at how you plot out tangent, and we kind of talked a little bit about this. At 0, y over x is 0 over 1. What's 0 divided by 1? 0. The next easy value to work with tangent is at 45 degrees, pi over 4. What was tangent at pi over 4? 1, because it's root 2 over 2 divided by root 2 over 2. So it's 1. And it's the same thing at the negative. So it's negative 1. Then what happens is you get up to pi over 2, you have 1 divided by 0. Can you divide by 0? No, it's undefined. So at pi over 2, we have to put asymptote. It's a vertical asymptote at pi over 2. Same thing if I come back around the other way at negative pi over 2. And we talked about why tangent are open circles between here and here. That's exactly why. It can't include. So tangent, what happens with the graph,
It's like a straight line there and then up there.
it's increasing like that. So tangent does that. It still curves, but it has a change of direction because of the sign change. Yep, it's a funky dance. And then this would be tangent to negative angle.
So we just have to plot the ones.
It's actually 5 because 2 of them are asymptotes.
Right.
Okay. Now, what happens here is that tangent is also periodic. Is that something always happens in here. Well, what is this distance from here to here? Count again.
It's pi.
It's pi.
Why?
Why? Because this is at negative pi over 2. This is at positive pi over 2. And this is at pi over 4. Sorry. I know. So tangent has a period of pi. Okay. There's asymptotes that occur. The asymptotes always occur at half the period. It's actually works out to be really, really easy to work with. So what we're going to look at here is just the generic form of tangent, basically your parent function. Your parent function of a tangent, y equals a tangent b of x. This a value is still kind of like that amplitude, whereas we were showing that it goes to 1. Well, if your a value is 3, it goes to 3. Okay. It's very, very easy to work with. The b value helps you to figure out your period. Your period now for tangent is, bless you, is pi divided by the absolute value of b. So instead of being 2 pi over b, tangent is pi over b. And then those asymptotes, when you figure out where your period is, the asymptotes are going to be 1/2 of them are on both sides of 0. That's why they say it's just multiplied by 1/2. Very, very easy to work with. You're going to have to trust it. Okay?
Wait, so your periods are 2 pi over the absolute value of b is 2 pi?
Yeah. Yep.
The asymptote is over absolute b, right?
Yeah, yeah. Sorry. It's very rare. I mean, your b values can be positive, so it's. I mean, I don't think we ever come across it in algebra 2. They might throw a negative at you later on. So, this is really easy to work with, guys. Very, very easy. Let me show you an example.
Okay. Go ahead.
I see what you did there. B. Do you get B values? Really B different?
I don't think she did that on purpose.
I don't think so either, now that I said that. So let's look at this.
Let's do it.
Y equals 3 halves tangent 4x. Once again, the first thing we're going to wind up doing is listing out our values.
A is 3 over 2. B equals 4. This is tough. Yeah, Mr. Nerdy, I don't know if I can handle this.
I know, I'm asking a lot. Now, your asymptote, when you find your asymptote, it's going to be 1/2 of pi over 4. And let me show you how this is going to work. It's going to be at pi over 8. And remember, these are vertical. What's the equation of vertical lines? X equals some number. So what happens here, since we're not worried about shifting yet, all of our tangent graphs are going to go through the origin. They're all going to go through the origin. When you have parent functions, they're always going to go through the origin, no matter what. Yes, ma'am?
After you shift it though, it can like
Yes.
not go to the
Yep, yep. Because each of these points can be moved up, left, or right, down, doesn't matter.
Oh, right.
So what we do is, the easiest way to plot tangent is when you plot your parent function, put the dot in the center, and then mark your period. Mark out your asymptotes. Your asymptote is going to be at plus or minus pi over 8. So negative pi over 8 and pi over 8. Now you just have to find 2 halfway points. So what's half of an 8? Pi over 16, very good. And then over here will be at negative pi over 16. My A values are what goes on the vertical axis, and since it's just 3 over 2, just mark 3 over 2. About here. And this would be at negative 3 over 2.
Sweet.
The A value is positive, so therefore it's going to be increasing going from left to right. So all you have to do is plot your points. One goes here. We already had this one, and one goes there. There you go. And that's, you can if you want. I'm not going to yell at you if you don't. Yes, sir.
What do you do if you have odd multiples?
What do you mean?
Like, this one I saw is like pi over 2. Wait, go back. Let's see this.
Yeah. Then you just have fractions at like 1/3, pi over 3.
No, just go back.
Just do it.
Back. Right there.
So your B value is 3. So if your B value is 3
No, about that. So pi over 2b.
at odd multiples, oh, it's just meaning that it's not going to occur. Here, let me show you. I know what you mean now. This is 1. Well, let's do this. 1, 2, 3. This distance is pi over 8. This distance is pi over 8. If I multiply this by 1, I'm here where there is no asymptote. Multiply it again. So this is the first one. This is your second row. This is your third one. If I want another pi over 8, it would be a solid. If I want another pi over 8, it would be a dotted. That's what that means. Okay? So when they're talking about odd intervals, if you're starting here at 0, this is 1 pi over 8 asymptote.
Oh, I get it.
2 pi over 8, no asymptote. 3 pi over 8, asymptote. Does that make sense?
Yeah.
That's what that means. I don't really worry about making more than one period because it's pointless. Well, there's points, but there's no reason to.
That was really funny.
Why do you have to be such a downer all the time?
You're hurting my feelings.
She's laughing. You hurt my grades. When you look
I
You hurt your grade. He just puts it in the grade book.
Oh, wait for it! She'll read it.
Yeah.
cone of silence?
Yes, oh my God, she would have to wear it at all times.
What's up?
The sticker in the corner.
What's happening?
All opposed? Say.
Because it's the point of inflection is halfway between 0 and the asymptote.
No.
You really would put one on a She would never.
All right, let's do a shift.
You know it.
Shifting. Shifting doesn't change.
Already.
Yeah, it's because you have to plot a parent function to shift.
I'm not ready for this.
I know, you'll be all right. So your parent function is what basically we've been working with just a second ago. The shift is the h and the k. The h and the k, they do the same thing as they did before. You have a horizontal and a vertical component to it. You're still going to plot your parent function, which is your a, b, and x, or your a and b, and your asymptotes. For all of those values, you're just going to move them left, right, up, and down. Now, asymptotes, since they're vertical asymptotes, and you're going to have to move them, which way are they going to move? Left or right, up or down?
Both ways. Left or right?
Left and right. Really going to move left, right. Because if I move them up and down, they don't really move.
Oh, you're right, you're right.
Okay. So your asymptotes will also have that horizontal component to them when you move them around. Again, really straightforward. The goofiest part with tangents is that you get a lot more fractions than you would with sines and cosines. That's really the only tricky part of any of this. But if you keep it, if you get lucky enough and you have even fractions, it's nice. If you start getting like pi over 7 and you got to cut it in half, then you get mad at me. And I don't care. I think it's fun. So let me just show you an example. Oh, again, if the a value is negative, instead of increasing up and right, it's decreasing. That's the only thing. That's what it means by being reflected around. Okay. It's pretty easy. If a is negative, you'll see it. It's just like sine and cosine will flip. Tangents can flip side to side also. So let's look at this.
Depending if A is positive or negative, it'll start going up, it'll start going down.
This one does not have a k value. I need a k value.
Plus 3. 7.
Plus 3.
Why would you pick 7? Why would you pick such a large number?
7's a cool number.
So in this case here, let's go through the whole shebang. Start out when you write it out, you have -2 times tangent of quantity x plus pi over 4, all plus 3. So we label out what we know.
A equals
What?
why?
Why?
Oh, it's only if it's in like the X, right?
Correct.
A equals -2.
So you know our a value is -2. Now, right off the bat, make a quick note for yourselves that since it's negative, your tangent's going to look like this. It's nice to remember that because tangents are different. You're not used to graphing them. So it's sines and cosines are pretty easy. Just go to the a. So your amplitude is still 2. It's not technically called the amplitude, but I forgot what it is.
I forgot what it is.
What's your b value?
Just pi over 4. Just kidding. I totally lied. I was just seeing if you were paying attention.
So what's your
You
period?
have to gang up on me.
Too late.
Hi.
How are you?
I'm getting hi.
Asymptotes.
Is 1/2 is pi over 2.
Asymptotes, we had x equals pi over 2,
Okay, closer.
and x equals negative pi over 2.
So could you just do plus or minus?
Yeah. Now be careful when you do that with your shift. More often than not, your shift won't be multiples of pi over, or plus minuses. You'll see it in a second. Okay?
Oh, I get it.
So now we actually have, we have an h value of negative pi over 4, or is it positive pi over 4? I forget.
Negative.
Negative, good, and a k value of 3.
Wait, so what do we do about the amplitude?
It's still where we mark it off. You'll see it in a second.
Is it still the absolute value of it?
Now, to this thing, we're going to have to move it what direction?
We're gonna have to move it this way and left and up.
Left and up, yes.
That way.
So,
These ways.
what I'm going to do is over-exaggerate going to the left because things are moving left a little bit more. I'm still going to plot my parent function. Parent function always goes to the origin.
Wait, if you have dotted lines already,
Yep. It's okay.
what
This is a great example of having two colored pens, or pen and a pencil, or something like
That is
that.
not working.
Oh, did Izzy freak out when you said you should have two colored pens?
I don't remember.
I have more in one minute.
What's that?
Never mind. It wasn't relevant to this, so.
Our period is at pi. Come on, guys. Our period is at pi. Asymptotes of pi over 2. Now I just got to plot in my extra points. What's halfway between 0 and pi over 2?
Pi over 4. Negative pi over 4.
Good. So pi over 4 here. Negative pi over 4 here. Our a value is negative 2, so I just mark off 2 on both of them. Since it is a negative a, it means it's going down from left to right. So it's going to be at negative pi over 4, positive 2. Pi over 4, negative 2. And how do we connect these dots? Dotted.
Oh.
What are you gonna say?
So just like we did before, we list out our ordered pairs. We have negative pi over 4, 2, 0, 0. Pi over 4, negative 2. In our asymptotes, we're at x equals negative pi over 2 and x equals pi over 2. I'm listing, bless you, I'm listing out both of them instead of plus minus because it's going to be easier to add and subtract to it. That's all.
Okay.
Now to each one of these points, we have to move to the left pi over 4 and up 3. So what's negative pi over 4 minus pi over 4?
Negative 1/2. Pi over 2.
Yeah, negative 1.
So negative pi over 4. What's 3 plus 2?
5.
It is. I was just checking to see if you're paying attention.
Yeah,
Good work.
Thinking.
Error 5 for Hannah.
It worked.
She did get the error 5.
Wow, Hannah. Wow.
Next one's at negative pi over 4.
I don't give
And
high fives
3.
to students.
I missed something. What happened?
Hannah, what'd you do?
You are an animal. That looks like a gravy boat.
Will somebody please take the gravy boat out of my back?
I got you. Oh.
Wow.
Have fun stabbing.
Thank you. Thanks for.
I don't high five.
Oh, you should have cut because it's a knife.
Pi over 4 minus pi over 4.
Zero.
0 and 1. And then our asymptotes. Moving your asymptotes, same thing. You just have to move them to the left. You don't have to do any vertical component to them because they're vertical asymptotes.
No way.
Yes way. So negative pi over 2 minus pi over 4 is?
Negative 3/4.
3 times.
And the other one is pi over.
You don't want to be at pi over 4. Okay. Now, when you go to plot these, yes, you're going to have a lot of overlap sometimes. If you look at your graph, you only really have to put in one extra value. It's the asymptote at negative 3 pi over 4. So here's our negative 3 pi over 4. It's our asymptote. My other asymptote is at pi over 4, so I put it in. My new ordered pairs are at 0 and 1. Negative pi over 4 and 3. Negative pi over 2 and 5. And our graph still does the same thing. And that's it. It may look like absolute junk, but you told me you ordered pairs correctly with math, and you're fine. I know, it's crazy how math works.
Can I tell you how to do it with ends?
That seems like a lot more work.
that would be
Okay.
so funny.
How do you deal with science?
I don't know, but I mean, English, they already added all the letters to it, so.
Oh, you're trying to be funny.
I'm not good at it at all, I'm sorry.
I've been trying to delay how long it keep her to keep her arm up in the air. No, the other person with the arm up in the air.
Wait.
Yeah, Claire.
Santa's arm was in the air when I looked up. Is that still me?
Who?
I was just. I want to see 3 pics.
He's not gonna.
Alright, what's up?
I just like to tell you about the Bible reform verse. Where did you? How did you? Oh, never mind. I just remember what you
Really?
were looking for.
You raised your hand that whole time. I remember.
Never mind.
You know, sometimes it takes a minute for someone to the brain cells to get jogged loose. They get stuck in muck.
Good conversation. It's just like what is this?
My old high school's phone number rhymed with truck.
Your number?
My high school's phone number rhymed with truck.
How?
Like duck.
Did it spell out the word the truck's at?
It might have.
Like with the number?
Yes.
No. It was with the letters. It was a phone letter. I'm so confused.
So, does anybody have any idea what's going on right now? Have we really gone off on a tangent?
You just sealed the deal that we didn't learn anything.
Peace out. Tip your waitresses, ladies and gentlemen.
3825?
Now we should just change it all.
Did you get your phone out to check that?
I didn't.
You realize that the numbers on a phone are the same as the numbers on a calculator, right?
Really? Why don't they have anything on one?
Actually not. You guys are wrong. Why not?
Think about it. The first 3 letters are in one. The second 3 letters.
But there are no letters. Yes, but 7 has 4 letters and 9 has 4 letters.
Are you kidding?
I'm dead serious.
Did you not know that?
No, that's not me.
Like,
Wait, what?
who's really the one not thinking?
You! It's always been you! Every day that I've been in this class, period 6, 7, it has been you.
Oh my god. Somebody needs to burn this on their DVD and put one of those time capsules.
What not to do, announcement 2.